Good morning, students. We're looking at decimals at the moment just to kind of review the unit circle. We do have a quiz over this today, but looking at this, you can see the different angles we can produce and the different points along the x and y. Remember, x correlates with cosine, y correlates with sine, and y divided by x correlates with tangent. And so as you can see, the function goes around, it tells us our x, again, and our y. So we're going to actually look at something a little bit different. We're going to be looking at whether or not we can find sine and cosine for any angle. So we do have one definition, that is reference angles. We'll cover that in a minute. In a little bit. Let's zoom in. We are covering section 4.4 today. So, few definitions. Let's remember what our definition was for the unit circle, which was y, and what our definition was for triangle. That was O divided by H. Cosine was x, or adjacent divided by h, hypotenuse, and then tangent was y divided by x. Sorry. Let's do that. Y divided by x, or O divided by a. Cosecant was simply sine, so this is 1 over y. Sorry about that. This is y. You put the equal sign, 1 divided by y, and or h divided by o. So we're just going through the basics. Okay, and then this is 1 divided by x, or h divided by a, and then cotangent is x divided by y, x divided by y, or a divided by o. Okay, so those are all our basic ones. Let's zoom in here so that you can see this. Okay, so these are our basic unit circle, where r equals 1, and triangle, where it's a right triangle. And so these are all our current definitions. Now let's expand it. So let theta be an angle in standard position with x comma y, a point on the terminal side of theta. And r equals the square root of x squared plus y squared. Okay, so r can never equal 0. Okay, this is going to expand our definition to any angle. Okay, so again, this is going to expand our definition. So we have theta, and this is going to equal y divided by r. Okay, now why is this different from our unit circle? Our unit circle has an r of 1. So of course, if you divide anything by 1, that equals itself. So this is just expanding it, so we don't have just acute angles or obtuse angles, but this is any angle along the circle. So again, this is a pretty simple one. Y over r, x over r, y over x, r over x, and then x over y. Okay, so definition right here. Let's zoom out slightly so we can see it. Okay, you can pause so you can write that down. We'll keep going. Okay, let's do the first problem. So first example is let -3, 4 be a point on the terminal side of the angle, find sine, cosine, tangent for the angle. Okay, so first things first, we have point -3, 4. And as any of you know, that's going to give us angle, if we draw it approximately, we have, so we have 4 height, it's this angle right here. Now, what is this hypotenuse? Well, this hypotenuse is just going to be 16 plus 9, square root of 16 plus 9, which is going to equal 5. So this equals r. So you solve for r, which is 5. Now we find sine of theta, and that equals 4 over 5, because y over r, and cosine of theta, which equals -3 over 5, and tangent, which of theta, which equals 4 over -3, -4/3. Okay, so those are our 3 positions. If you have any questions, you can feel free to ask me during class how we do some of this. But let's continue on. ASTC. This is a crucial acronym. ASTC. Let's zoom in for this so that maybe we can see this better. ASTC is going to give us what is positive. So, ASTC functions this way. First, quadrant 1 means all. Quadrant 2 equals sine. Quadrant 3 equals tangent. And quadrant 4 equals cosine. What's that mean? Well, let's look. So, quadrant 1, everything's positive, right? Okay, quadrant 2, what do we look at? Sine is positive. Quadrant 3, tangent's positive, and quadrant 4, cosine's positive. So, ASTC tells us what is positive and what is negative. Now, why is that important? Well, that's important because there's one other thing, special triangles. There are 2 triangles you should know. You should know 45, 45, 90, and 30, 60, 90. If you know both of these, you know every angle in the unit circle. And quite frankly, even more, you know every angle, every standard angle. Okay. Now, let's look at this. So, given ASTC and special triangle. So, if tangent is negative and cosine is positive, what position would that be in? Well, let's look at our circle. Okay, tangent and cosine positive, cosine tangent negative, tangent's positive here, cosine's negative, cosine's positive, tangent's negative there. So, the only position that works for is quadrant 4. So if we look at that, if we actually draw out the triangle that we're getting, sorry about this. So if we draw out the triangle we need, we get a good look at what we're dealing with. So, start with our standard position, and this is going to be -5, -4. So, this is going to rotate around this way. This could be here. This is going to be +4 right here, -5. So, if we do the calculations, r will equal 25 plus 16. What does 25 plus 16 equal? The square root of 41. So r equals the square root of 41. What are we solving for? We're solving for sine of theta and secant of theta. So sine of theta is going to equal negative 5 divided by square root of 41, which if you rationalize the base is going to equal negative 5 times the square root of 41 over 41. And secant is going to equal 4 over the square, sorry, not 4. It's going to equal radius over x, which equals square root of 41 over 4. So our answer is that way, okay? So first step, we needed to find what quadrant it was in. Second step, we draw our triangle. Third step, we split it. Okay? That should be it for now. There's the second part, which is evaluating cosine tangent functions for the 4 quadrant angles, 0, pi over 2, pi, and 3 pi over 2. And you can do that on your own. I will start with reference angles next video.